Tonight, I want you to forget everything science fiction has taught you about the stars. Forget the giant spaceships gliding effortlessly across galaxies. Forget the idea that humanity will simply advance enough and someday spread across the universe like it's our destiny. Because the deeper physicists looked into reality, the more disturbing the truth became. The universe is not built for easy travel. In fact, hidden inside the laws of physics are barriers so powerful, so absolute, that they may permanently separate humanity from the stars we've dreamed about for thousands of years. And yet, that's exactly what makes this story so fascinating. Because this is not just a story about rockets or space travel. This is a story about the limits of human ambition itself. It's about what happens when the most intelligent species on Earth collides headfirst with the fundamental structure of reality. Tonight, we are going to explore why space is far more terrifying than most people realize, why even light struggles to cross the galaxy, why time itself begins to break apart at extreme speeds, and why the universe may have placed invisible walls around every civilization that has ever existed. But here's the strangest part of all. The more impossible interstellar travel appears, the more valuable the dream becomes. Because every great achievement in human history began with someone staring at an impossible horizon. So stay with me until the end of this journey. Because what you're about to hear will completely change the way you look at space, physics, and humanity's future among the stars. Humanity has always looked at the night sky with the same dangerous thought. What if we could go there? Every civilization imagined the stars as destinations waiting patiently for explorers. Ancient people drew myths around them. Sailors navigated beneath them. Scientists measured them. Engineers dreamed about reaching them. And somewhere deep inside the human mind lives the belief that no frontier can remain closed forever. But the universe does not care about ambition. Nature is not impressed by courage. Physics does not negotiate with dreams. The first hidden law standing between humanity and the stars is distance itself. Space is so enormous that the human brain quietly refuses to understand it properly. We speak casually about stars as if they are neighboring islands across an ocean, but the nearest star beyond our sun is more than 4 years away, even if you travel at the fastest speed nature allows. Think about what that means. Light itself, the fastest thing in existence, takes over 4 years to reach Proxima Centauri. Light can circle Earth 7 times in a single second, and even that incredible speed still crawls helplessly across interstellar space. The terrifying part is that our fastest spacecraft are not moving anywhere close to light speed. Voyager 1, one of the greatest engineering achievements in human history, would need tens of thousands of years just to reach another star system if it were aimed correctly. Human civilization itself is younger than that journey. Entire empires rise and collapse faster than a spacecraft could drift through the darkness between stars. Suddenly, the universe stops feeling like an open ocean and starts feeling like a prison built from unimaginable emptiness. People often assume the solution is simple: build faster engines. But that idea crashes directly into one of the most brutal laws in physics. The universe has a speed limit, EMC2. This equation is not merely famous because it looks elegant. It hides a terrifying truth. As an object with mass moves faster and faster, the energy required to continue accelerating it rises dramatically. Near the speed of light, the required energy becomes so enormous that it approaches infinity. Not very large, not difficult, infinite. The universe literally refuses to allow massive objects to cross that boundary. This changes interstellar travel from an engineering problem into a fundamental conflict with reality itself. You cannot simply invent a stronger engine and escape the rule. Even if humanity built a spacecraft larger than cities, Powered by the energy output of entire nations, the speed of light would still stand there like a cosmic wall saying, "No further." And yet the situation becomes even stranger. Suppose somehow we could approach light speed. Strange distortions begin happening to space and time themselves. Time slows down for moving objects. To astronauts aboard a near light speed ship, the journey might feel short. A crew could experience only a few years, while decades or centuries pass on Earth. Delta T, delta T2, Salt C2, that equation describes time dilation, one of the strangest discoveries ever made. Time itself stretches depending on motion. A traveler moving close to light speed does not experience reality the same way stationary observers do. Imagine leaving Earth knowing that when you return, everyone you ever loved could already be dead. Languages changed, nations vanished, history rewritten. The stars are not merely physically distant. They are separated from us by time itself. People sometimes romanticize this idea, but it reveals something horrifying about the universe. Physics allows you to move into the future, but not together. Interstellar explorers would become disconnected from humanity. Every mission would create loneliness on a scale no human psychology evolved to survive. The explorers who reached the stars might no longer belong to Earth by the time they arrived. Then comes the problem of energy, which may be the most underestimated obstacle of all. Moving even tiny objects near light speed requires absurd amounts of energy. The energy needed grows so rapidly that interstellar travel begins demanding resources comparable to planetary civilizations. A spacecraft is not just moving itself. It must accelerate fuel, shielding, life support systems, habitats, food, water, and all the machinery needed to keep fragile biological creatures alive in a deadly vacuum. Imagine throwing a baseball. Now imagine trying to throw a mountain at nearly the speed of light. That is closer to the scale of the challenge. The universe is astonishingly unforgiving about momentum. Again, you not math, but caught what? Always prefetch A2, the content, PMV, on momentum grows with velocity, and once enormous spacecraft reach relativistic speeds, stopping them becomes another nightmare entirely. A ship traveling close to light speed carries catastrophic kinetic energy. Even slowing down at the destination requires another gigantic energy expenditure. Humanity does not merely need engines powerful enough to accelerate toward the stars. We need engines powerful enough to survive the entire round trip. And all this assumes the spacecraft survives the journey itself. Most people imagine space as empty. That is one of the greatest misconceptions ever created by science fiction. Space contains radiation, stray atoms, microscopic dust particles, magnetic fields, and high-energy cosmic rays constantly moving through the galaxy. At ordinary speeds, these dangers are manageable. At relativistic speeds, they become lethal weapons. A grain of dust striking a spacecraft near light speed would hit with explosive energy comparable to powerful bombs. Tiny particles become bullets. Atoms become radiation beams. Empty space transforms into a firing range. Cosmic radiation is especially terrifying because it attacks life at the cellular level. Human bodies evolved beneath Earth's atmosphere and magnetic field, both of which protect us from dangerous radiation. Outside that protective cocoon, the universe becomes biologically hostile. DNA damage accumulates. Cancer risks rise dramatically. Nervous systems degrade. Cells mutate. Long-term exposure slowly poisons living tissue. Shielding against radiation sounds easy until you calculate the mass required. Thick shielding makes spacecraft heavier. Heavier spacecraft require more energy. More energy requires more fuel. More fuel increases mass even further. Physics traps engineers in vicious cycles where every solution creates another impossible problem. Then there is temperature. Space is often described as cold, but that statement hides a deeper complexity. In space, Managing heat becomes extremely difficult because there is almost no matter available to carry heat away. Spacecraft generate enormous amounts of thermal energy from electronics, engines, life support systems, and human activity. On Earth, heat escapes into air and water. In space, radiation is almost the only option. The faster and more powerful your spacecraft becomes, the more dangerous waste heat becomes. A civilization attempting serious interstellar travel would confront thermodynamics at every moment. Dist delta SGIC 0. That tiny expression represents the second law of thermodynamics. Entropy always increases. Every machine wastes energy. Every engine leaks heat. Perfect efficiency does not exist. Nature taxes every action. Interstellar travel demands gigantic energy systems, which means gigantic waste heat problems. Eventually, physics asks a brutal question. Where exactly will all that energy go? Human biology introduces another hidden barrier. The body was designed for Earth. Bones weaken in microgravity, muscles decay, vision changes, the immune system behaves strangely. Even short stays in space produce measurable physical deterioration. Interstellar travel would require humans to survive years, decades, or generations away from Earth's environment. Psychology becomes equally dangerous. Human minds evolved under blue skies, gravity, weather, sunlight, and social communities. Imagine spending decades inside artificial metal habitats surrounded by endless darkness. No open air, no natural ecosystems, no escape. Generational starships sound exciting until you realize entire societies would live and die trapped inside machines without ever touching another world. And then comes the cruelest possibility of all. Perhaps nature never intended biological creatures to cross interstellar distances physically. Perhaps intelligence emerges locally, explores locally, and remains trapped locally by the structure of space-time itself. Some dream about wormholes or warp drives as loopholes around these problems. The equations of general relativity do allow bizarre possibilities where space-time bends, stretches, or connects distant regions. G me nu nu, G C4, T me nu nu. This equation describes gravity not as a force pulling objects, but as the curvature of space-time itself. In theory, if space-time can bend, perhaps shortcuts through the cosmos are possible. But theory and reality are enemies more often than friends. Wormholes appear to require exotic matter with negative energy density He, something never confirmed in usable amounts. Warp drives may demand impossible energies larger than entire stars can produce. Once again, physics teases humanity with mathematical possibilities while slamming shut every practical door. Even communication across interstellar distances becomes tragic. Messages traveling at light speed still take years, decades, or centuries to arrive. A conversation between stars becomes impossible. Human civilization depends on rapid exchange of information, trade, cooperation, and culture. Across interstellar scales, civilization fragments into isolated islands, unable to communicate in meaningful real time. The stars begin to look less like destinations and more like separate universes. And yet humanity keeps dreaming because there is something deeply rebellious about consciousness itself. Physics may place limits around us, but intelligence constantly searches for cracks in the walls. Every major breakthrough in history once looked impossible. Flight looked impossible. Moon landings looked impossible. But splitting the atom looked impossible. But interstellar travel feels different because the obstacles are not merely technological. They are woven directly into the fabric of reality. The universe is not just challenging us, it may be warning us. Perhaps the hidden laws blocking humanity from the stars exist for the same reason oceans once blocked primitive civilizations. They force intelligence to evolve before gaining greater power. A species capable of surviving interstellar distances would need mastery over energy, biology, psychology, material science, and perhaps space-time itself. Such a civilization would barely resemble modern humanity, because the true enemy is not distance alone, it is fragility. Humans are astonishingly delicate creatures trying to cross an environment designed to destroy delicate things. We survive only within a thin layer of atmosphere on a tiny rock orbiting an ordinary star. Beyond that thin protective shell lies a universe filled with radiation, vacuum, gravity waves, relativistic violence, and incomprehensible scales of space and time. The hidden laws of physics are not simply obstacles. They are filters. They separate dreamers from realities. They determine whether civilizations remain trapped around their home worlds or rise into something greater. And somewhere out there, among billions of silent stars, may exist the answer to a terrifying possibility. Maybe every civilization eventually discovers these same barriers and realizes the cosmos is far harder to conquer than imagination ever believed. And so we arrive at a humbling truth. The universe has never promised us the stars. It has placed before us distances so vast they defy imagination, speeds we cannot surpass, energies we can barely comprehend, and laws so absolute that they seem designed to test the very limits of intelligence itself. The hidden laws of physics are not just equations written on a chalkboard. They are the invisible boundaries of reality, the silent rules that every civilization, no matter how advanced, must eventually confront. But perhaps that is not a reason for despair. Perhaps that is the reason to keep going, because humanity has never been defined by the ease of its journey. We are defined by our refusal to stop asking impossible questions. We looked at the oceans and crossed them. We looked at the sky and learned to fly. We looked at the moon and left footprints on it. Every generation inherits a new impossibility and then dares to challenge it. Maybe we will not reach the stars in our lifetime. Maybe we will not solve these mysteries for centuries. But every equation we understand, every spacecraft we launch, every child who looks upward and asks, "What's out there?" That is how the journey begins. The stars may be far away. They may even be beyond our reach, but the act of reaching for them is what makes us human. And perhaps the greatest lesson physics teaches us is this. Even when the universe says, "No," curiosity still whispers, "Try again." So keep wondering, keep questioning, keep looking up, because somewhere in that endless darkness, hidden behind the laws that challenge us, may lie the next great chapter of human destiny. Good luck on your own journey of discovery, wherever it takes you. Thank you for watching, and never stop chasing the impossible.